So, remember that song. I'm going to come back to it in just a second. I hope you can hear it. I have my speakers plugged in. But remember that song. That was Rocco, Squares Out Your Circle. So, I'm back on page 224. So same section, it's just a different theorem. I know you're thinking that we skipped one, and I did that on purpose. I don't want to talk about 6.14. I'm going to skip right to the top of page 224. It says angles outside of the circle theorem. So read that for yourself. It says if a tangent and a secant, two tangents or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference. Underline that for me. Underline the difference of the measures of the intercepted arcs. That's a lot of words. So let me explain what it actually means. So anytime you have two lines that intersect, any two lines that intersect outside the circle, two lines that touch the circle but they intersect outside of the circle, if I want to find out what the angle is, whatever the measure of the angle that's formed by this intersection, what I'm going to do is take the difference between the bigger arc and the smaller arc. So the idea is if I want to find the measure, for example, of angle 2, I'm going to take 1/2 and multiply it times the difference. What happens when I subtract angle PQR arc PQR minus this arc PR. Now, this is going to be weird and corny, but you won't forget it. This is one of the few theorems, or one of the few properties where we actually use subtraction instead of addition or multiplication. And the way I remember it is, well, if I have two lines that are meeting up outside of my circle, think about your circle, or think about your friends. If they're meeting up outside your circle, it's time to get rid of them. It's time to subtract them. So, this is one of the few where we're actually going to subtract, and I told you it's lame, it's kind of corny, but you probably won't forget it. So let's actually, this is actually one of those properties where it's easier to understand if we actually do it first. So let's come down to example 3. So for example 3, I have a circle. See this diagram, my upper right. I have a circle and I see two lines that come to meet outside of my circle. What are two lines doing meeting outside of my circle? Gotta subtract them. Have to subtract them if I want to find out what this angle is. That angle X. Have to subtract them because they're meeting outside of my circle here at point G. So if I want to find the measure of angle FGH, that's this angle here. It's going to be 1/2 of the measure of this big arc, that major arc, or it might not be, it's actually not a major arc, but the bigger arc, which is arc JF, minus the measure of this arc here, the smaller arc, which is arc FH. Now, essentially what I'm doing is I'm going to subtract this 170 minus the 72, and then multiply it times 1/2. So, calculators, 170 minus 72, that's going to be 98. Now, I'm going to multiply that 98 times 1/2. It's going to give me 49. That's my answer for the missing angle. X is 49 degrees there. So, just that simple. Two lines that are touching my circle, but they're meeting outside of the circle, got to subtract them. Got to take them away and multiply by 1/2. So, scroll down to the checkpoint. Let's see what we know. I'm right below the example at the checkpoint. So we're looking at 3. So question number 3 is actually a little tougher. Checkpoint number 3 is actually a little tougher. You know what I want to do instead? Turn over to page 225. Let's actually look at number 11 on page 225. Then we'll come back to checkpoint number 3. So for question 11, once again, they give me a circle And I'm able to see that two lines are touching my circle, but they're meeting outside of the circle. So what are we going to do? We're actually going to subtract. So looking at number 11, if I want to figure out what this angle 1 is, it's going to be 1/2 times. Now once again, since they're meeting outside of my circle, I'm going to subtract. I'm going to subtract 92 minus 43. So if I take 92, subtract it from 43, I get 49. And it's going to be the same as 1/2 times 49. Or we can call that 24.5 degrees. 24.5 degrees for the measure of angle number 1. So that's an example of how you would do a basic problem where two lines intersect outside of the circle. So now we've seen how to do a basic problem, let's go over and look at checkpoint question number 3, back on page 224. So as I look at question 3, I see this time we already know what the angle is. This time they want me to find the missing arc. They want me to find this missing arc Y. So usually what happens is I subtract one arc from the smaller one and I multiply by 1/2 and I get the missing angle. So we can kind of come up with an equation so we can solve for x. So usually it's x degrees. That's usually the angle that we're looking for. X would equal 1/2 times, I'll say, big arc minus small arc. That's usually how we find x. So now we have an equation that we can kind of substitute in for. So this time we actually know x. What is the included angle this time? What is the angle that we typically solve for when the lines intersect? We said it's 26 degrees. So instead of saying x this time, I'll say 26 degrees. Now 26 degrees equals, once again, 1/2 stays the same. Now, big arc. Do we know what the big arc is? Well, no, that's actually what we're looking for. They call the big arc y, so let's call it y. 1/2 of y minus the small arc. And what's the small arc? You see that the small arc is 30 degrees. 1/2 minus 30. So, let's simplify this one step at a time and solve for y. So now I have 26 equals 1/2 y minus 1/2 times 15. All I did was distribute that 1/2. Did 1/2 times y minus 1/2 times 30. So 1/2 of 30 is 15. It's my new equation. So 26 equals 1/2 y minus 15. What am I going to do to both sides first? I'm going to add 15 to both sides. So now I have 41 equals 1/2 y. 41 equals 1/2 y. So at this point, I only have one step left to solve for y. And since this is 1/2 times y, you can think about it two ways. I could divide by 1/2. That certainly would work. That's the same thing as multiplying by 2. So if I multiply by 2, the 2 and the 1/2 will cancel out. And then I have 2 times 41, which is 82. That equals y. 82 equals y. So that's an example of how you would solve a tougher problem using that outside the circles theorem. So now that you've seen both types of questions, you understand the theorem, and you understand when you're supposed to subtract people out of your circle, I want you to go back to page 225. Here are the questions I want you to work out on your own. Questions 10, 11, and 12. Then flip over to page 226. I want you to work questions 13, 14, and 16. these tougher questions. For question number 10, I'm going to give you one hint. We know that they're 360 degrees in a full circle. They gave you 270 degrees for one of the arcs. There's only 2 arcs there. Now we can subtract to find out what that missing arc is. All right. Thank you. Let me know, as always, if you have any questions. I'll see you on Monday or Tuesday.